Okay, this is our last kind of factoring for this unit. It's called factoring by grouping. So the first thing we're going to do is look for a GCF in the first two terms and a GCF in the last two terms. And then once we factor out that GCF, we're going to factor out that greatest common factor in parentheses one more time. Go ahead and pause this video and write down the steps. When you're ready, these are our examples. So in that first example, they've already done some grouping. They've grouped together the first terms by factoring out what was in common, and they've grouped together the last two terms by factoring out what they had in common. But if you notice what's in parentheses, those are very, very similar terms, but they're actually opposites of each other. So for example, let's say I had the binomial 2 minus x. If I wanted to flip the order of those terms, as you know, I would factor a negative sign out. That would allow me to bring the x to the front and make it positive. That would move the 2 to the back because it would now become negative. So if I want, on example 1, if I want the terms in parentheses to be the same, on the second one, I have to factor out a negative. So I have a negative 2a in front. That allows me to flip the order of those terms. The a becomes positive and the 3 becomes negative. And then that first part of the expression just stays the same. Now the goal is factoring. We're not multiplying out, we're not distributing, we're factoring. So if you notice, now these terms in parentheses are the common factor. So I'm going to pull that a minus 3 to the front because that's what we have in common. And then I'm left with 5 minus 2a. So I factored this by grouping. The first two terms were grouped together, and so were the last two. Now, if we want to make this a have a positive coefficient, usually you want your variable to have a positive coefficient, we can again flip the order of those terms by factoring out a negative. And that's going to bring the 2a to the front and the 5 to the back. I'm going to put the negative in front of everything. If I were to put the negative between the parentheses like this, that would no longer be a multiplication problem, that would be subtraction. So you would need parentheses or something around it to show that you're multiplying, but I can just factor that negative out and put it in front of the entire expression. Okay, number 2. Now these terms aren't grouped. We're going to do the grouping ourselves. So when you do factoring by grouping, often there's 4 terms. So we're going to look for the greatest common factor in those first 2 terms. Well, they both have an x in common. The smallest power of x that I see is an x squared. So we're factoring an x squared out of those first 2 terms. And what we have left is an x minus 5. Now we look at the last 2 terms and factor out their greatest common factor. If the first term is negative, we're going to factor out a negative. Those 2 terms have a 6 in common, so we're factoring out a negative 6. So factoring out a negative 6, we're left with x minus 5. Don't forget to flip the sign or take the opposite of the sign when you factor out a negative. Now looking, we have like factors or common factors in the parentheses. So we have an x minus 5 in common, that gets factored out. When you factor out the x minus 5, we're left with an x squared and a minus 6. Every time you're done or you think you're done factoring, you need to make sure that you can't factor any further. So if you look here in the parentheses, that kind of looks like a difference of 2 squares, except the 6 is not a perfect square. So we can't factor it anymore. We're actually done. The 6 was something like a 4. We could factor that one more time. Okay, example 3. So we have 4 terms again, and even though those middle terms are like terms, we could combine them, but we're not. We're going to keep them separated, and we're going to factor by grouping. So we're going to look at those first 2 terms and look at what they have in common. So those first 2 terms only have an x in common. Let's factor out the x, and we're left with 2x plus 3. Now we look at the last two terms. Recall, if the last two terms begin with a negative, we're going to factor out a negative. So negative, and their greatest common factor is 4. They have a common factor of 2, but their greatest common factor is 4. So factoring out a negative 4, we get 2x, and then negative 12 divided by negative 4 is plus 3. Now look, the 2x plus 3 is the common factor. That gets factored out to the front. And what remains is the x minus 4. We move that to the back. The last problem has 4 terms also. So looking at the first 2 terms, let's identify what they have in common. So those first 2 terms have an x squared in common. So let's factor out the x squared. So dividing by x squared, we're left with x minus 5y. Looking at the last 2 terms, again, if the last 2 terms start with a negative coefficient, we factor that out. So we're left with minus 9y squared. That's the common factor of those last 2 terms. So when we factor that out, we're left with positive x and then minus 5y. So everything in the parentheses should be the same in order to proceed. If this is not the same, you can't proceed, and maybe try a different method of factoring, or possibly look for an error. So let's pull that common factor out to the front. And then we're left with an x squared minus 9y squared. But look, this last binomial is a difference of 2 squares. So we can keep going. So we're going to leave that first one as is and factor the last as a difference of 2 squares. X minus 3y and x plus 3y. Okay, and at the bottom of that flap, we're going to go ahead and write the name of this, which is called factoring by grouping. One more quick note I want to make. Actually, let's go ahead and do an example 5. Let's say that we had, say, x cubed minus 8x squared plus x minus 8. So there's something a little bit different about this problem. In the first 2 terms, let's factor out an x squared. And then we're left with an x minus 8. So sometimes you get something like this, where the last 2 terms, I don't see a common factor. If you don't see a common factor, just factor out a 1. So when you factor out a 1, you're left with x minus 8. So now we can keep going because the terms in parentheses are the same. So factoring out that x minus 8, what's left over? The x squared and the plus 1. Now in the parentheses, in that second set of parentheses, we have an x squared plus 1. This is prime. We can't factor a sum of 2 squares, so we're actually done. Even though there's a squared on that x, we are done with that problem.